Hello, everyone. We're the Apprentec nativebot team with voice recognition and audio translation for Triquivajo. I'm Chris.
And my name's Alexia.
Triquivajo, a language in crisis. Triquivajo is an indigenous language spoken mainly in Oaxaca, Mexico, and it is critically endangered. There are only about 5,000 speakers left. Most of them are elderly people, and that number is shrinking with every generation. What makes this especially hard to address is the complete absence of digital tools. Translation services such as Google Translate have zero coverage for Triquivajo. There are no voice interaction tools, no apps, no learning platforms built for this language. It has been entirely left behind by modern technology. So if you're a heritage speaker trying to reconnect with your roots, a learner who wants to understand your family's language, or a community member who wants to teach, there is simply nothing out there for you. That is the problem we set out to solve, and our solution is ApprenTech and its core feature, nativebot. Nativebot is a voice-driven translation platform built specifically for Triquivajo. The idea is simple. You speak a word or phrase in English or Spanish, and you get back the Triquivajo translation paired with authentic audio recorded by native speakers. The goal isn't just translation, it's about helping speakers and learners actually hear the language, the real pronunciation from a real person in the community. We also wanted to make this accessible on both mobile and web, so the barrier to get started is as low as possible.
One of the most significant changes we made during this project was to the core translation approach. Our original plan was to fine-tune a speech recognition model on Triquivajo audio so that native speakers could speak into the app and be understood directly. That required a minimum of around 500 word recordings. We collected 253 within our timeline, which was not enough to train a reliable model. Given that constraint, we reversed the direction of translation. So instead of recognizing Triquivajo speech, the user speaks in English or Spanish. Google Cloud speech-to-text transcribes that input, and our backend searches a database for a match. If one is found, the Triquivajo translation and its native audio are returned to the user. We also made changes to how the data is structured and stored. The original database used a single collection where every Word document contained all of its translations embedded directly inside of it. The problem with that structure is that adding a new language would have required updating every single record in the database. We restructured it into three separate collections. Base content holds English and Spanish word data. Native translations is its own collection that links back to the base content and to a specific language. And native languages serves as a registry for every language the platform supports. With this structure, adding a new language requires a single database insert. No existing records need to be touched. We made a similar change to our AWS S3 storage. Previously, there was no organized folder structure. We reorganized it so that each language has its own folder with subfolders for audio and images. This keeps the storage organized as the platform grows. This slide walks through the full technical pipeline from the moment a user speaks into the app to when they hear the translation back. It starts with the user tapping the microphone button and saying a word in English or Spanish. The Flutter app handles the recording on the mobile side, and once the user stops speaking, the audio is automatically sent to our backend. The audio then goes to Google Cloud Speech to Text, which transcribes the spoken input into text. We evaluated a few options during development and landed on Google Cloud for its accuracy with both English and Spanish. Once we have the transcribed text, it goes to our Python Flask backend, which is the central connection point for the whole system. Flask takes the word, runs a search against our MongoDB database, and looks for a match in either the English or Spanish field. If a match is found, Flask retrieves the corresponding Triquivajo translation and the native speaker audio file stored in AWS S3. It generates a short-lived secure link to that audio so the app can stream it directly without exposing permanent file paths. Flutter then receives that response, displays a translated word along with an image or digit if one exists, and plays the native audio automatically. The full round trip from speaking to hearing the translation takes a few seconds.
what we delivered. So what did we actually ship? Number one, a working native bot. You speak a word in English or Spanish, and you get the Triquibajo translation and native audio back. That core feature works end to end on both mobile and web. Number two, an expandable language database. The schema supports multiple languages. Users can select which language they want to translate to, and adding a new language requires just one new document. Number three, native bot on the web. It's not limited to just the mobile app. We built it into the Apprentic web dashboard so that it's accessible from any browser. Number four, we reorganized the AWS S3 storage. Content is now organized by language folder, each with dedicated audio and image subfolders, clean, scalable, and ready for more. And this here is our actual app. On the right, we have our homepage where users have access to the My Interpreter, native bot, and they can explore language and culture. In the middle, we have our dictionary where a user can look up a word in either English or Spanish, and our app retrieves the Triquivajo translation as well with the audios for each of the three languages. And in case the word has an image or if it's a number and it has the digits, that is also displayed. On the right, we have our native bot feature. And this is a GIF showing a user speaking into the app and the app retrieving the correct translation for the word that was spoken. In this case, monkey.
So to summarize where the project landed, we have 253 native audio recordings in the database, 557 translated words, and the platform is accessible on iOS, Android, and the web. The project shifted direction along the way, but the core goal stayed the same. Users can speak a word in English or Spanish and receive the Triquibajo translation with native speaker audio on any of those three surfaces. The database is also structured so that additional indigenous languages can be added without changing any existing records. What started as a capstone project has become a working platform for a language with almost no digital presence. And that brings us to the end of our presentation. We want to thank our mentor Aurelio Lopez, whose community connections and guidance shaped the direction of this project from the beginning. And thank you for your time.